This is the first in a series of 4 videos covering the first lecture of the Computer Fundamentals topic at the IES Information Technology course. This first video deals with introducing the concept of decimal numbers and the binary number system, and also how to convert a binary number into its decimal representation. Have you ever wondered why we use 10 digits in our number system? It's simply because people come with a standard issue of 10 fingers. We use 10 distinct digits: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And then we combine digits to form other numbers using place value. As an example, let's unpack what 15037 means in such a way that it's of use when we investigate how the other number systems we're investigating work. Let's start by putting each of the digits in the top row of a table. Each digit has a place value. For example, the 5 tells us the number of thousands in this number. In the case of base 10 or decimal numbers, we have little trouble in saying what each place is worth. They're simply the powers of 10. We start with 1 in the rightmost column of our table and then increase as we move left. Some relatively simple high school maths tells us that when we write these numbers as powers of 10, we start at 0, as 10 to the 0 is defined to be 1, and we increase again as we move left. Therefore, our 5 in its place tells us that this represents 5 by 10 to the power 3, which we know is 5,000. And we can fill in the rest of the bottom row of the table easily, but noting that the 0 digit indicates that there are no hundreds in this number. This is important later when we convert from other bases to decimal. It's conventional when working in multiple bases to write the base of the number we have written as a subscript after the number as shown. In summary, the decimal number system uses 10 digits, 0 through to 9, and place values are given by powers of 10. By contrast, the binary number system, which is used by computers, is base 2, not 10. It has only 2 digits, 0 and 1, and the place values are given by powers of 2. Binary is used in computers and other electronic devices because they are what is known as two-state devices. The current is either on or off, 1 or 0. So how can we calculate the decimal equivalent of a binary number? The simplest way is to use a table similar to the one earlier in the video. So here's the question: what is the decimal equivalent of the binary number 10110? Now the second row of the table, instead of being the familiar powers of 10, becomes the powers of 2, starting with 2 to the power 0 on the right and increasing as we move left, just as before. The third row contains the decimal representations of the powers of 2, starting with 1 on the right and increasing as we move to the left. The bottom row shows the place value, and because the digits are either 1 or 0, we either copy the decimal power of 2 into the bottom, or we put a 0. In this case, the binary number is 16 plus 4 plus 2, which is 22. And this is written in base 10, so we need to indicate it with the appropriate subscript, like this. Let's use a table with more columns to calculate the decimal equivalent of 101110110. Now it's your turn. Try these. Pause the video as you do them. If your answers don't match these, don't panic. Try again and ask if you are still struggling. The next video will deal with converting between decimal and binary numbers.